Hello everyone, I am Alok Kumar and I welcome you to this fourth lecture in the 5 lecture series on straight lines. We already have covered much ground and today we'll be looking at more challenging problems. So let me now share my screen with you all and start the lecture. Okay, so last time we had looked at many of the problems and concepts. One interesting problem that I will like to start the class with is this. It's again trying to find the locus. So there is a triangle ABC. So ABC is a triangle. It is right angled. So it is given that it is right angled at C and its ends A and B. Its ends A and B. They are on the positive. They are on the positive x-axis and y-axis respectively. So they lie on x and y respectively, one on each. And your job is to find the locus of C. So it's like it is sliding. So there is a triangle. So I can just label them. So this is the triangle C and this A and B. So ABC is a triangle. Right angle at C, that's given. This is your positive x-axis. So I can write OX and OY. And this triangle ABC it ends A and B on the x-axis and y-axis, and it slides on it such that A and B always are on the positive x and y-axis respectively. You want to find the locus of C. It's a challenging problem. If you're looking at it the first time, then please attempt it yourself. You can attempt yourself and grab the piece of paper. But anyway, I have to tell the solution. So I will start like this. I'll give some motivation. That suppose I write C as alpha comma beta. So that's the first step always to find locus, that we start by naming the point C or whatever point I have to find locus, and we call it alpha beta or HK, whatever you want to call. So don't call it XY, because calling it XY may interfere with your axis X and Y. So don't do this. This is not allowed. So better you call it alpha beta or HK as you like. Alpha beta I'll go with. So alpha beta is the coordinates of C. They're the coordinates of C. And now I want to find the locus of C. I can drop perpendicular. So I'll do by 2 methods. So let me say this is my first solution. So let me draw a new diagram without disturbing the original one. So this is C, A, and B. Now I can drop a perpendicular from C onto, say, OA, that's x-axis, and also on y-axis. Let's name them. So these perpendicular foot are named as M and N. So the construction is that from C, drop the perpendiculars on x-axis and y-axis, call them M and N respectively. Now C is alpha comma beta. And one angle, this AB anyway is joined because AB is the sides of a triangle. I can take this angle to be theta. So angle ACM, I designate as theta. I take as theta. Then angle MCB, because angle at C is 90, that's 90 minus theta. So this angle is 90 minus theta. And so this little angle, this angle, that's this angle BCN, that's again theta, because it's 90 minus theta. So that you have got theta. So these two angles are each theta. This is theta and this also is theta. Now, from triangle AMC, you have got right angle triangle AMC, this triangle AMC. I can write that CM equals AC times cos theta. And AC is, of course, B. So I will get B cos theta. Let's write this as B. AC is B. And, of course, BC also is A. So CM is B cos theta. And CM is also the height of C above M. And so I can write CM as beta, the y coordinate. That's all right. Similarly, if I get to triangle B and C, in triangle B and C, I have got this NC or CN. So Cn equals BC times, again, cos of theta. BC is, of course, A. So that's A cos theta. And Cn is also alpha, because once you have got this C, and then if you are dropping perpendicular from C, so this is M and N, C is alpha and beta. So it means this distance is alpha and this distance is beta, by virtue of alpha beta being the coordinates of C. So we are good now. We got B cos theta is beta. So let me record it. So beta is B cos theta and alpha is A cos theta. We got these two things. Theta is the parameter, and that I can eliminate now. So it is simple. I just divide. So beta over alpha is B over A. And so the locus of alpha beta, if I write alpha first, it's B alpha minus A beta is 0. So this is the locus of alpha beta. I can generalize alpha beta to current point, and let's call it x comma y, as is the usual tradition. And so our locus happens to be bx minus, this is b alpha minus b alpha minus, this should be a beta. So I'll write this as a. So that's a beta. So bx minus ay equal to 0. And that's what my locus is, bx minus. Such a simple locus, but still the problem is far from simple. It's a challenging one. Little charming, but more challenging. Okay, let's do it by another method. My second solution is pure geometric. So let's draw the figure again. So this time we have got again this triangle. The triangle is A, C, and B. Let me draw this also. This is AB as the side of the triangle. This AC is B, BC is A, all those things. And let's join this one. Let's join this O to C. Now C, as usual, I have taken as alpha comma beta, because this is the point of which I have to find the locus. So if I take this alpha comma beta, first I observe, I draw it separately. I observe this quadrilateral, the quadrilateral AOACB. The quadrilateral OACB is cyclic because the sum of opposite angles is 180 degree. Precisely angle AOB and plus angle ACB, that equals 180 degree. And so this is cyclic quadrilateral, meaning that a circle can be drawn. And so this is a circle can be drawn through it. And so you have got these two lines joined, so OC and AB. Now I can say by the properties of angle in the same segment that if I consider segment AC, then this angle equals this angle. Means angle AOC equals angles ABC. Both are made by segment AC. Both are made by AC. Segment AC on this one, on the same side, and so they are equal. So let's call them. Let's call it phi and phi. So they are phi. So now I have got two things for phi, two expressions for phi. One is that tan of phi, this is your phi. So one is tan of phi is simply slope of line OC, and that equals beta over alpha, because beta minus 0 over alpha minus 0 is the beta over alpha, m of OC. And also I can find phi from triangle ABC, which I reproduce here. So we have got the triangle ACB, and this is 90, this is phi, and AC is B as usual, and BC is A. I can get an expression for tan phi here from this right angle triangle, and tan phi equals B over A. If that is the case, B over A, then these two must be equal, and we get beta alpha is B over A. That's completely agrees with what we got here. Let's go back and see that beta by alpha over B by A, that's here. So it means second solution also we got the same thing. And so we are getting that, okay, geometrically also it is possible. So look at how cleverly we made use of the fact that the collateral was cyclic, and using that we are able to get two expressions for tan of phi, and we are equating them. So in maths, it's a good idea to get something in two ways and equate that. That is the thing we always do. Okay. Next, I will do some problems on pair of lines. So just give you a brief review that if you have ax square plus 2hxy plus by square is 0, that represents pair of lines. So it's pair of lines passing through origin. So that's passing through origin And if I can write this as ax squared plus 2hxy plus by squared is y minus m1x slope and y minus m2x, I must write b here because coefficients of y squared must be same. And when you do that, you are getting b times y squared minus m1 plus m2 xy and plus m1 m2 x squared. And by equating the coefficient, y squared coefficient, you get nothing. And then you get 2h xy coefficient is minus b times m1 plus m2. And x squared coefficient a, that a you will get is b times m1 m2. So we are getting m1 plus m2 equals negative 2h over b, and m1 m2 is a over b. It's hardly surprising because what you are doing inside that you are putting y equal to mx sort of, and m has two values, m1 and m2. And so if I put y equal to mx in our equation, I'll get ax squared plus 2h and then xy. So I will get 2h x times mx and plus b times m squared x squared is 0. As x is not always 0, this gives bm squared plus 2hm plus a is 0. And because m has two values, so by Vieta's equation or relation between roots and coefficient, m1 plus m2 equals negative 2h over b, and m1 m2 equals a over b. And so we are getting that product of slopes and sum of slopes. These are fundamental equations we'll always use. Now there are a pair of lines passing through origin. If you have something ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c is 0. Now this is a second degree curve, like, and then the condition that happens, that that necessary condition. So the necessary condition that it should have a separate equations of pair of lines, means it represents pair of lines, is that there is a term called this one, abc plus 2fgh minus af squared minus bg squared minus ch squared equals 0. This equals 0 because this is the condition that you get when you arrange them as a linear expression, as a quadratic expression in x, that is ax squared, and you take all the terms of x together. So you get like 2hy and then plus 2fx, and then you are getting 2hy plus 2f times x, 2hy plus 2fy. So let me write it again. So this is like, so we are trying to arrange a quadratic in x. So I'll get ax squared and then 2hxy terms that will add up with this one, this one. And so we'll get, this is 2hy plus 2g and times x, and then by squared plus 2fy plus c is 0. And we can now apply discriminant non-negative and other conditions. So you will get this condition ultimately. This is used in exam often. So you have to commit it to memory and you have to just practice some questions on it. This will be normally a lengthy business, but I will tell you in this lecture how to make it, how to shorten it. Now, this is one. And then sometime you're also asked that find the separate equations. So find the separate equations of the lines, if at all they represent lines. So let me take one example which will put these things in action. So our example happens to be that we have got 2x squared, locus is 2x squared plus 5xy plus 3y squared and plus 6x plus 7y plus 4 equal to 0. And I want to find out these pair of lines. So in objective, choices will be that this represent pair of lines and the angle between them is, or something similar. So pair of lines, I will be giving you pair of lines. So you find me pair of lines. So this is one pair of lines finding. Then their point of intersection, which is not origin now. Point of intersection, it's not homogeneous. And third is that you have to find, in fact, angle between the lines. So it so happens, this is the main question, is pair of lines. Once you find that, other two will follow. So let's do it. I tell you two methods. So you will find that second method is superior. But let's do first method also because it's more instructive and it's instructive method. And of course, you are using your good old quadratic. So first of all, you want to find out that whether they represent a set of lines. So you're writing 2x squared plus 5xy plus 3y squared plus 6x plus 7y plus 4 equals 0. Now arrange them as a quadratic. So arrange them as a quadratic in x or y, whatever you like, depending on coefficients. I choose x here. So what I will do, that I will arrange them as a quadratic in x. So I'll write here as 2x squared. So 2x squared term is copied, and plus 5xy, and these terms come. So I can take common, and I will get 5y plus 6 times x, and then plus, this is 3y squared plus 7y plus 4. So let's check our work. 3y squared, 7y plus 4. So this is what we are done, that we have arranged as a quadratic in x. Now it's like ax squared plus bx plus c is 0, where of course coefficient a, b, c, they are not numbers. They may depend on y. That's not a problem. Still, I can write x as negative 5 or 6 minus b plus minus square root of b squared. So 5y plus 6 whole square minus 4ac. That's 8 times 3y squared plus 7y plus 4, and over 2 times 2. So let me simplify this term. So this term becomes square root of, this is 25y squared plus 60y and plus 36 minus 24y squared minus, this is 56y. So that's 56y and minus 32, and that gives you y squared, and then plus 4y and then plus 4. That's amazing. It just turns out to be perfect square. So you recognize that this is nothing but y plus 2 whole square, this one. And so you have got your x as negative of 5y plus 6 and plus minus, this is y plus 2 over 4. I can take 1 plus 1 negative 1. So negative of 5y minus 6 and plus y plus 2 over 4. Or I can take x is negative of 5y negative of 6 and negative y negative 2 over 4. That simplifies. So I can write this as negative of 4y and then negative of 4 over 4. That gives negative y minus 1. And this side you have got this as negative 6y and then plus 8 and over 4. And so I can write this as x plus y plus 1 equals 0. That's one line. And this line I can write 4x is negative 6y plus 8. And that gives me 4x plus 6y minus 8 equal to 0. This is also negative 8. So I will write 4x plus 6y and plus 8 equal to 0. So we got these two lines. So first part is over. Second, third, quite routine. We want to find point of intersection. That is simply x plus y plus 1 equals 0. And 4x plus 6y plus 8. That I can write as 2x plus 3y plus 4 equal to 0. So let me write in this way. And so I'll get your x plus y plus 1 is 0. And here 2x plus 3y plus 4 is 0. I can multiply the first by 2 and subtract. So I will get 2 of y plus 2 minus 3y minus 4 equal to 0. So negative of y, negative of 2 is 0. So y plus 2 is 0. I get y is negative 2. And from that x I get, so x I will get as negative y minus negative 1 and negative 1 plus 2, that's 1. So I'll get 1 comma minus 2, and that's my point of intersection. So I got 1 minus 2 as point of intersection. It means that we have got these things. And third is that angle between lines. So it may be a more than one choice questions where you have different parts. So don't make a mistake. So x plus y plus 1 equal to 0, that has got m as negative 1. And 2x plus 3y plus 4 is 0 has got m as negative 2 over 3. And so I will call them m1 and m2. And you want tan theta angle between the lines. That's m1 minus m2 over 1 plus m1 m2. I'll take the mod because I'll report the acute angle unless asked otherwise. And that equals -1 minus -2/3. Don't make a mistake. And 1 plus -1, -2/3. Make good use of the brackets. So -1 plus 2/3 and 1 plus 2/3. That gives you -1/3. And this is 5/3. And that's, of course, everywhere modulus is coming, mod absolute value. And so I get 1/5. And so I can write that tan inverse of 1/5 is indeed the angle between the lines. So for this, let me go back and show you what we actually did. That we were to find the separate equations of the lines, because once that is found, you can answer any questions. And normally they are asked in more than one choice, so that you have got some time and there is some more credit, like 3 marks or 4 marks. So now you want to find pair of lines, also want to find point of intersection and angle between lines. So first method was that arrange them as a quadratic in x or y, whatever you wish. So I have chosen x here. So arrange them quadratic in x. So it looks like this one. It means that coefficient of x and the constant term, now a, b, and c, they may be a function of y, which they are. Here is constant 2, b is a function of y, c also is a function of y. I can solve them as a quadratic in x. So x is -b plus minus square root of b squared minus 4ac over 2a. And that result ultimately happens because square root happens to be the perfect square. That's expected, because if it is to be a straight line, so we got perfect square. That will also guard you against mistake. If you're not getting, means something is wrong. You check your work. So we got perfect square. That was not coincidence. It was expected. This was expected. And so once you get that, then I am getting the component lines, separate equations, of which the above was the combined equation. And so we got two lines, x plus y plus 1 is 0, and this is nothing but 2x plus 3y plus 4 is 0. I can solve them to find point of intersection. I can find their m1 and m2, and then I can find their angle also. So that is one method. I will use the second solution, which may look somewhat different. You might not have seen, but you will soon have the benefit of it in the next example, which will be really tricky if you do by conventional method. So second solution is like this, that first of all, I already know the second degree terms. So what I do, that I will combine second term, 2x squared plus 5xy plus 3y squared and plus, so let me copy, 6x plus 7y plus 4 equal to 0. I see that I know all the terms here. So I will factorize this. That's step one. That factorize this term means factorize second degree terms. Leave aside this one, second degree terms factorize. Because everything is known. If it is not known, I'll tell you what to do. Now factorize this means it is just quadratic. I'll write 2x squared plus 5xy plus 3y squared is, that's 2, 3, 6, and 2 plus 3, 5. So that's simply 2x squared plus 2xy plus 3xy plus 3y squared. So 2x is common. I can take a factor, x plus y. 3y is a factor, x plus y. And so I get 2x plus 3y and times x plus y. So already I got this. Slopes are determined. Now only thing is left of the constants of the equation. So what I do, that based on this factorization, I can write 2x squared plus 5xy and plus 3y squared plus 6x plus 7y plus 4 as, look at it carefully, 2x plus 3y plus some lambda and x plus y plus some mu, where lambda, mu are constants, they are numbers. So they are constants to be determined. To be determined because factorization is not complete right now. Now this happens, and this we can tell that they are equal. So we can equate coefficient of x squared, xy, y squared, coefficient of x, y, and constant term. This will not give anything new, x squared, xy, y squared. Already we used it to decompose this into this part, this one and this one. So they won't give anything new. They will just give equals, 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 equals. So that is like a equal b, because a and b are equal. So this is no new information. This is no new information. Already we have squeezed information out of it. So that has played this part well. Now x coefficient. So x coefficient on left side is 6, so I write 6, and x on left side on right side is 2x. 1 will come from here, 2x mu, so that's 2 mu, and then lambda, so 2 mu plus lambda, that's the coefficient of x. And then coefficient of y on the left side is 7. On the right, let's get the coefficient of y, so 3y, that will give you 3 mu, and then plus lambda because lambda y, so you get 3 mu plus lambda is 7, and constant term on the left is 4, and on the right is lambda mu. Now it must strike you, or it must have struck you already, that why the hell there are 3 equations when we need just 2? We need just lambda and mu. So what on earth these 3 are doing? That is simple. What is actually happening is that you have imposed the condition that this is factorizable like this, but we do not know yet. So it means they all must be consistent. That's the fine point. They all must be consistent. If they are not consistent, it means the way we have assumed them, you have assumed this factorization is not true, and indeed the conclusion is that you cannot factor like this. It's a beautiful method, just go with the flow of it. So the theoretical concept is this, that because you are telling that this can be factored, so these all must be consistent. Means I can find lambda and mu from any 2 equations, but then third also must be satisfied if I plug in lambda and mu. So obviously I would choose linear one. I will choose first and second these one. So I will choose 2 mu plus lambda is 6, and 3 mu plus lambda is 7. So I see I can quickly find lambda because I can subtract. I can even mu rather subtract. So I'll get mu equal to 1. And once mu equal to 1, I will get lambda equal to 4 from equation 1 only, lambda equal to 4. But now I find that the third one, the remaining one, lambda mu is 4. So lambda mu is 4 is satisfied. Okay, done. It checks out. It checks out. And so indeed, this factorization is possible. This is possible. It is possible to write like this. In the process, you have got the line. So you have got the line as 2x plus 3y and plus lambda 4 is 0. And you got x plus y plus mu, x plus y plus 1 is 0. So you got the separate equations of line. Separate equations of line. And that was the beauty of this method, that ultimately you got this. It's a really beautiful method. Please get used to it. I'll do one more problem. So once you get the equation of the line, nothing is now undone because you can answer all the parts. That was the main thing. Next, this one, it has got quite crazy answer. And often when I have given this problem to children, often they have not come up with the correct answer, because answer, of course, eludes you. So this says like this way, that 6x squared plus 2kxy and plus 12y squared plus 22x, they are big coefficient, plus 31y plus 20 equal to 0. So you are given that this represents a pair of lines. That's given to you, pair of lines. Now I ask you find k, or how many values of k, or what k are there. This is the whole thing. Find the values of k. So 6x squared plus 2kxy plus 12y squared plus 22x plus 31y plus 20 equal to 0. That represents a pair of straight lines. Find k. Now my first thought would be that, of course, there is a nice result, that we know that ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c equal to 0. This represents, so if this represents a pair of lines, then abc plus 2fgh minus af squared minus bg squared minus cg squared equals 0. We can, of course, attempt them. You can try them. So let's choose the coefficient. So coefficient here are not very good. So a equals 6, h is nothing but this k given, and then b is 12, g is 11, f is 31 over 2, and c is 20. If you do this, abc plus 2fgh, if I plug them, a is 6, so I'll get 6 times 12 times 20, and plus 2 times 31 over 2, so that is 2fgh. So 2 times this times k minus 6af squared. So 6 times 31 squared by 4, and minus 12 times 11 squared, and minus 20 times k squared equal to 0. So first of all, Cortican is coming, and it's very ugly, but we don't have any choice. So let's multiply. So that is 24 and 6, so 144. So 1440, and plus this is 2 cancels, and this is 341. So 341k. This is 31 square is 961, and 961 to 6. So that gives you this one. And so you will get here 2883. So this is, you are getting 2883 over 2. And then again you will have other thing also. So that is your this one. This is 31 to 11. This is 31 squared. So you will get 1452 by, and then minus 20k square is 0. Means you collect these terms, you will get this kind of coefficients, which is not very good because there are a lot of terms. Okay, so once I get that, then how do I proceed? So of course I have no business but to write all the things. So if I write all the things, I will get here 40k square minus 682k and plus 29070. Just check it. This kind of thing you will get. Of course, that's too much laborious to get. And still, imagine after this also you have to get k equal to 682 and plus minus this 682 whole squared and minus 4 into 40 into 2907 and over 2 into 40. If you do the work, you will get out to be 682 and plus minus 62 squared. You will get 465 and 124 and minus 465120 after calculation and over 80. And that you will get 682 plus minus 2 over 80. And so finally, you will get this as 684 over 80 and 680 over 80. And so you will get the answer as two answers you'll get. One is 171 over 20 and one is 17 over 2. Now that's really long and bad because ultimately you have to do this is lots of calculation. And then IIT advanced exam or mains, you have got time is always at premium. So it's better not to follow this method. But I'll tell you alternative which you won't find in books. So let us go back and let me tell you how nicely to do it. So second solution is the one which you will prefer this any day. So what I will say that compared last time, here now k is not known. So I can't factorize second degree term. Or unlike this one, let me go back where I did. This is factorized because 5 I knew. Here I am stuck because I don't know this k. No problem. What I will do is that I will do something different. So I know that this is not, k is not known, but x squared terms are known. So I'll write 6x squared and plus this. First, let me write the equation 2kxy plus 12y squared and plus 22x plus 31y plus 20 equals 0. What I'll do that I will collect x squared, x and constant term. So let me do the background work. 6x squared plus 22x plus 20. I will factorize this first. So I can take 2 out and 3x squared plus 11x plus 10. And this is 3, 10, 30. So it is 6 and 5. So that is 3x squared and then 6x plus 5x plus 10. That is 2 times 3x, x plus 2 plus 5 times x plus 2. So I got 2 times 3x plus 5 and times x plus 2. I can also write this as 2x plus 4 and times 3x plus 5. Means I cleverly factorized the term x squared, x and constant term. Now I will say that this now only y is missing. So I will write 6x squared plus 2kxy as I did last time, 12y squared plus 22 in the previous problem, 31y plus 20. I will attempt a factorization that this equals 2x and plus 4 is there. So 2x plus 4 and plus lambda y, some y thing, and then 3x plus 5 and plus again y thing, mu. So lambda and mu the coefficient. So this should be my factorization. Let me now collect coefficient. So again you have x square, xy, you've got y square, then x, y, and constant term. Now x square already we are done with. It won't give new information, x and constant. So these things are no new information. Already we have squeezed the information out of them. So they don't anything new. Now xy. Let's calculate xy. On the left side xy equals 2k. Let's say 2k. On the right side xy. So from 2 you will get first 2 mu, that is 2 mu xy. And 4 won't give you xy. Lambda will give you. So 3 lambda. So 2 mu plus 3 lambda is 2k. So that's first. Then y squared. Now y squared you won't get from x, you won't get from y, you will just get from lambda and mu. So that is y squared is left side is 12. So 12 is lambda times mu, that is y squared. And let's come to so xy, y squared, and y. And in y we'll get y, so 2x is now y. From 4 you'll get 4 mu, this is mu, you'll get 4 mu. So this left side is 31y. You will get right side 4 mu and plus lambda y, so you will get 5 lambda. So 4 mu plus 5 lambda. 4 mu plus 5 lambda is 31. So we get these two numbers. Now again same thing, we have got three equations. Let's call them 1 and let's call them 2 and 3. Again, what on earth these three are doing? Only 2 are enough to determine the value of lambda and mu. So I told you that use the 2 to find lambda and mu, and third to check that they are indeed true. So what I will do, that I will use 2 and 3 because anyway k is not known. So this time, and of course k will get determined. So I will get lambda mu equal to 12 and 4 mu plus 5 lambda is 31. Let's eliminate one of them. So let's eliminate mu. So 4 times lambda over 12 plus 5 lambda is 31. So I multiply throughout 48 plus 5 lambda squared is 31 lambda, which rewrites 5 lambda squared minus 31 lambda plus 48 is 0. That's 1. And I can have 48, I can factorize. So 48 is 3 times 16. And if I write 16, 15, then it is done. So 5 lambda squared minus 15 lambda minus 16 lambda plus 48 equals 0. Now I can take 5 lambda common. Lambda minus 3, negative 16 lambda minus 3 is 0. So I get lambda minus 3 and 5 lambda minus 16 is 0. And so lambda has two values. That lambda is 3 and lambda is 16 over 5. When lambda is 3, because lambda mu is 4, check out lambda mu is 4, and so mu becomes 3. And when lambda is 16 over 5, then mu becomes, because product is 12, 12 over 16 over 5. So 12 into 5 over 16, that gives me 4, 3, 12 and 4, 4. So that gives you 15 over 4. So you get lambda mu ordered pair. And now I want to find the value of k. Now that's an easy job. I'll just complete it. So 2k is, let's scroll back. 2k is 2 mu plus 3 lambda, or 3 lambda plus 2 mu. So 3 times lambda. So once lambda is 3, so 3 times 3 plus 2 times 4. That is your 9 plus 8, 17. So 1k becomes 17 over 2 that we got last time. We got by long calculation. This is infinitely better. Now 2k is again 3 lambda plus 2 mu. So for the pair, this pair, lambda is 16 by 5. So 3 times 16 by 5 plus 2 times mu, that is 15 over 4. So this is 48 over 5 and plus 15 over 2. I can take this 10 as LCM. This is 96 and this is 75. So that gives me 190. This is 96 and 75, so it gives me 171 over 10. And so k happens to be 171 over 20. And so we got these two crazy values that we got last time also. But of course in exam you won't be able to complete by the first method. It's too laborious. So follow this method, indirect method of factorizing. It is really great. And besides, you get to learn some new things also. So you have got k2 values, 17 over 2 and 117 over 20 to get it done. Some problems come like this, where it is easy to factorize. That we will do like this, that it is given that some again lines are there. So the equation 8x squared plus 8xy plus 2y squared plus 26x plus 13y plus 15 is 0. Again, you have to find out that represent a line. In fact, I will say that represent pair of parallel lines. Find them, and also the distance between them. This is to be found out. So one solution, that method 1, again I will instruct as arrange a quadratic in x. So I can write 8x squared plus 8y plus 26 times x, this one, and plus 2y squared plus 13y plus 15 equals 0. So I can write x as negative of 8y plus 26 plus minus 8y plus 26 whole squared and minus 32 for AC 22y squared plus 13y plus 15 over 2 times 8. So this is what I can write, arranging as a theme, as a quadratic in x, that we have done. So let's see how we get it. Then I'll tell you one more method. So now this number is, you leave, let's play with this one. So square root of 8y plus 26. So I can write this as, I can take something common. So, or I can write simply 64y squared plus 2 into 8 into 26, that is 1626. That gives you 416. So 416y, and then 26 squared, that is 676, and negative of 32 into this is 2y squared. This is just simple 2. So I'll just erase it. Simple 2. Watch out here. This is 2. So that is 64y squared. And then minus again 3 to 13. So that is 416y. And then minus 480. And so you find that this is just a constant. So this is just, when you write, this is root 196. And so you are getting this as minus of 8y plus 26 and plus minus 14 over 2 into 8. And so in the first case, I can write x as negative y minus 26 and plus 14 upon 16. That is minus 8y, and minus 26 plus 14. So that will give you minus of 12. So minus 12, and then upon 16. So I can write this as 4 as common. So this is minus 2y minus 3 by 4. So you will get 4x plus 2y plus 3 is 0. That's one line. And the other line is by taking negative. So I can take x is negative y, negative 26, and minus 14 over 16 again. So this is negative 8y, and negative, this is 40 over 16. I can take this time 8 out, so negative of, so 2 and negative of 5y. So I'll get this as 16 and this is 2. So I can get 8 out. So this is minus y and minus 5. And so I can get 2x plus y plus 5 equals 0. So obviously these two lines, you can see that they are parallel lines. So let me arrange in the form. So this line is 2x plus y plus 5 is 0, and this line is 2x plus y plus 3 over 2 is 0. And so they are parallel lines. One is 2x plus y plus 5 is 0. Other is 2x plus y plus 3 by 2 is 0. So distance between them, d, is c1 minus c2, and over square root of 2 square plus 1 square. So that you will get as 7 over 2 root 5. So that's your distance between the lines. So that is one method of doing it. The second method, you have to just observe something that we failed to notice last time, that if you write this one 8x squared, 8xy, 2y squared. So let me copy it first. 8x squared plus 8xy plus 2y squared plus 26x plus 13y and plus 15 equals 0. Now, if I take this one, I can take 2 common, that is 4x squared plus 4xy plus y squared. And interestingly, 13 is common here. That's 2x plus y, and plus 15 equals 0. Now notice that this is 2 times 2x plus y whole squared plus 13 times 2x plus y, and plus 15 is 0, meaning that I can take 2x plus y as t. It's a quadratic in t. That will happen for kind of parallel lines. So this is 2t squared plus 13t plus 15 is 0. And now I can solve it. This 215 is 30, and 30 I have to break. So now what we will do, that we will just have some kind of this one, that we can just find some factorization. So what that factorization will be, and how will you get the answer now? So the idea is simple, that we can again write either factorization, or we can write plus minus, but factorization works better. So 2t squared plus, this is 10 times 3, 13, 30. So 2t squared plus 10t plus 3t plus 15 equals 0. Or we could have done t equal to negative minus 13, but this is preferred first. So now this is 2t and t plus 5, and plus 3 times t plus 5 equals 0. So I can write 2t plus 3 and times t plus 5 equals 0. So our line is 2t plus 3 is 0, 1, and one is t plus 5 is 0. Now let's see what t was. T was 2x plus y. So 2x plus y is there. So 2 times 2x plus y plus 3 is 0, and 2x plus y plus 5 is 0. So we got 4x plus 2y plus 3 equals 0, and you got 2x plus y plus 5 is 0. So this is the method that you will do in exam or something, because that's really smart method, and it gives you result in short time. So just find these 2 methods. So first method I told you was instructive, that you can always arrange a quadratic in X. If you fail to notice this, some people may fail to notice. Not all will be, because exam, under pressure of exam, people may forget. The other method, that if you substitute parallel lines, then it must be a perfect square. This second degree term perfect square. So that signals in line chapter. On conic it is different. If it is line, then you know that it is a straight line, then you know that it is parallel lines. So this is this one, provided this discriminant is non-negative, other things taken care of. So you got this one. Interestingly, this also is there here. So it is quadratic in 2x plus y. So let's write t, and then we solve for it. And these are my component lines, and we can answer all the questions now. Let's do one more kind, which is telling you this one, that now you want to find out that you want to find the combined equation. So you want to find combined equation of straight lines. So combined equation of straight lines that passing through 1, 1. So passing through 1, 1, and parallel to the lines given by x square minus 5xy plus 4y square plus x plus 2y minus 2 equal to 0. Means you want to find the straight lines passing through 1, 1. So you want to find this passing through 1, 1. So these two are lines, some lines. This is pair of lines. So call it something, some locus C, that is pair of lines. So L1 and L2, they meet at some point. And you want from some other point, 1, 1, you want parallel to them. So this kind of thing you want. So these lines and parallel to them. It may be somewhere else. So notice that here, I need not find all the lines. Okay, second question can be that find the lines themselves. Find the lines themselves. Then you do all the work. So find the lines themselves will be same thing, that arrange as quadratic in X. So I'll get x square and minus 5y minus 1 times x, because this is here, and plus 4y square plus 2y minus 2 equal to 0. So it's like ax square plus bx plus 6, arranging as a quadratic in X, and then noting that we can still have quadratic in X. So I will write x as 5y minus 1 and plus minus root of 5y minus 1 whole square minus 4 times 4y square plus 2y minus 2 over 2. And if I notice the part that is inside, so I'll write square root of, so this part, so I will drop the square root, I'll just calculate this and then take. So this is 5y minus 1 whole square minus 4 times 4y square plus 2y minus 2, that will give you 25y square minus 10y plus 1 and minus 16y squared minus 8y plus 8, and that gives you 9y squared minus 10, so minus 18y and plus 9. I can take 9 common, that's y squared minus 2y plus 1, so that's 9 times y minus y whole squared, and so that gives me square root is 3 times y plus 1 squared, so I get x is 5y minus 1 and plus minus 3 times y minus 1 over 2. I can take one plus sign, one minus sign. So x is 5y minus 1 plus 3y minus 3 over 2. And x is 5y minus 1. And then I can take negative sign, negative 3y plus 3 over 2. And so x equals, this is 5y plus 3y, that is 8y minus 4 over 2. That is 4y minus 2. So one line will be x minus 4y plus 2 is 0, x minus 4y plus 2 is 0. And from here, it is 2y plus 2 over 2, so y plus 1. And so I can write x minus y minus 1 is 0. So I can find these 2 points. And also, I just want to find the pair of lines through 1, 1. Let's check through 1, 1 I want. So it means I need just slope. So slope of one line m is 1 over 4. And slope of one line m1, m2 is 1. And so from 1, 1 I want. So it's just that this does not interest me anymore. So if you talk of this one, this is x minus 4y is lambda and passes through 1, 1. So this is 1 minus 4. So x minus 4y equal to negative 3. So that is your equation. So x minus negative 3. So x minus 4y plus 3 equal to 0. That is my equation 1. That one line parallel to this one. And the other line is m2 is 1. So I'll get x minus y equal to some mu. And 1, 1 lies on it. So 1 minus 1, that is 0. So x minus y is 0. So you'll get other line as x minus y is 0. So these are the 2 lines that are parallel to it. And I can also write combined equation. Sometimes they ask you. So combined equation is x minus y and x minus 4y plus 3 equal to 0. That simplifies x squared. And then we can just have the whole thing. So x squared and minus 4xy plus 3x minus yx plus 4y squared minus 3y equal to 0. So you get x squared minus 5xy plus 4y squared and plus 3x minus 3y equal to 0. So that gives you just that the equation of that pair of lines. Now, if your job is only to find pair of lines, then this is not needed. What we can do is that we know that this second degree term, that only give you the slope. So if you just have to find parallel lines, I will write that x square minus 5xy plus 4y square equal to 0. This will give me slopes of line. So I'll just write y equal to mx. So that is 1 minus 5m plus 4m square is 0. So that is 4m square minus 5m plus 1 is 0. I can find m from here. So that is 4m square minus 4m, m equal to 1 is a root, 4m, and then minus m plus 1 is 0. That's 4m, m minus 1 minus 1, m minus 1 equal to 0. So this is m minus 1. So that's m minus 1 is 0. So I'll get 4m minus 1 times m minus 1 is 0. I'll get m is 1. M is 1 over 4. And m is 1. So of course I get x minus y is lambda. And 1 over 4. So I get x minus 4y equal to mu. As usual, I can find because 1, 1 lies on it. So 1 minus 1. And this is 1 minus 4. And so I will get the equation as usual. So this is 1. So such equations really come. let me take up a more challenging problem, which is given like this, that you have got two sides of a triangle. So you have got two sides of a triangle given by ax squared. So you are given by ax square plus 2hxy plus by square is 0. That's two sides of a triangle. So we can call them something. And orthocenter H is given to be x1, y1. So let's say that we have got OAB, and this OA is y equal to 1m1x. This is m2x. So this is the combined equation, by square, usual equation. And then your job is to find equation of AB, third side, equation of AB, third side. That's a challenging question. So what I do first, that I will write A, I will take A as some number. So let me take A as alpha and m1 alpha. So I'll take alpha and m1 alpha. And similarly, I can take B also, but let's do with alpha m1 alpha. So if you have got alpha m1 alpha, then what I can do is that I have got now the slope of this one, because H is given to be x1 y1. So H is x1 y1, and alpha m alpha is there. So what I can write, that slope of this I can write, that is like x1 y1, this slope. So let's say that this slope is y1 by x1, and so slope of AB is negative of x1 over y1, because OH is perpendicular to AB. So it means if I know the slope of B, if I know a point on A, then my job is done. So I will write the equation as x1. So I can write as x1 and plus y1 and equal to lambda. That I can write. That is my equation. Now it is easy to get. What I do now, that already we know that this is perpendicular. So this is AH perpendicular to OB. So I can write y1 minus m1 alpha over x1 minus alpha, and that times slope is m2. So m2 equal to -1. If that is the case, then I can write here that y1 minus m1 alpha and times m2 is alpha minus x1. So y1 m2 minus m1 m2 alpha is alpha minus x1. So I can solve for alpha, that is alpha times 1 plus m1 m2, and that I can write as x1 plus m2 y1. So I got alpha equals x1 plus m2 y1 upon 1 plus m1 m2. That's my alpha. Now that line passes through the point, this point, the line passes through alpha m1 alpha. So I can write here that x1 plus y1 is lambda, and it passes through alpha m1 alpha. So I can write alpha x1 and plus y is m1 alpha. So m1 alpha times y1. So I can write alpha times x1 plus m1 y1. Now alpha I know. This alpha is known to me from here. So I can write x1 plus m2 y1 over 1 plus m1 m2 and times x1 plus m1 y1. So I can write like this. Now I can just multiply. 1 plus m1 m2 is here, that we leave. We have got x1 squared and plus here m1 x1 y1 plus m2 this one. So we will get x1 plus this one m2 y1 and plus, so let me write it again. So we'll get this kind of thing. We'll just get 1 plus m1 m2, and then here we will get x1 squared plus x1 m1 y1 plus m2 y1 x1 and plus m2 m1 y1 squared. And in the last, I can write m1 plus m2 m1 plus m2 is negative of 2h over b, and I can write m1 m2 is a over b. If you do this, then we will end up with x1 plus y1. That number you will enter as bx1 squared minus 2h x1 y1 plus ay1 squared over a plus b, because 1 plus m1 m2 will give you a plus b. And so I can write as a plus b times I'm sorry about that, x1 plus y1, and that I will give at bx1 square minus 2h x1 y1 plus ay1 squared. So that's my locus. That's my equation of third side, that this one. So in this problem, you found that you have to do a lot of calculation. So sometimes it can happen that problem is this one, more general, and so you have to have all the approaches. So best is that you write a and then try to find other things like slope or other thing. Okay, so that's so it's time to go. So let me stop sharing now. Okay, so that's all for now. So let us meet tomorrow.